Telecommunication Engineering Module 4. We will discuss switching system today. Switching system is basically broadly can be classified into two types: manual switching and automatic switching. So automatic switching further can be classified into two types: electromechanical switching and electronic switching. So electromechanical switching is some kind of mechanical switch controlled by electrical pulses or electromagnet. This can be classified into two types: Strowger switching and crossbar switch. Electronic switch is basically called SPC, stored program concept. Basically some kind of instruction called program can be inserted inside a microprocessor or computers, and that will execute the task. Electronic switch can be classified into two types: space division switching and time division switching. Time division switching can be two types again: digital and analog. This digital counterpart can be classified into further three types: space switch, time switch, and combination of that. We will discuss one by one, but in this scope we will discuss this electromechanical portions only, that is Strowger switch and crossbar switch. So Strowger switch, as the name suggests, in the name of A.B. Strowger, who invented that switch in 1891. So this Strowger switch consists of basically several parts. This thing is called armature. This is being supported by some fixed contacts, okay, having some electromagnet here. These are the input portions of pulses to the electromagnet. This armature is being supported by two. One is horizontal, this one is horizontal, and on vertical spring, having some pulse here. This is called pulse. We have some wheel here called ratchet wheel. Wheel is having some fixed indicator type of thing called wiper. This is detained to fix that wheel here, and we have several contacts. This wiper is basically is the connectors between this wheel and the contacts. Fine. So let us consider the example of some rotary dial system. This picture may not be the clear on. We have some, this is finger stop. We have some digits like say 0, no, not 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. We have 0 over here, okay. Now if we dial this 1, it will release one number of pulses. If we release 2, it will release two number of pulses. Just what happens in case of pulse dial system. Now let us consider we have dialed 2 here. This 2, we have dialed this 2 here. Now it will generate two number of pulses. So for the first pulse, it will come here. This is the input portions. This first pulse will come here. Now this will energize that electromagnet, and we have some attracting force between this armature and this electromagnet here. Now this will pull that armature down. Now what happens? This ball will go downward. Now it will catch again, because of this spring. Whenever this electromagnet is energized, it will slightly go to this direction again. It will slightly go to this direction, and it will come downward again. So what will happen? It will just go lower, downward to catch this teeth. That means one teeth lower, okay. Now whenever this pulse passes completely, that means we have this break portion. After this make portion, we have this break portion. Then what will happen? This electromagnet will lose its energy. then this armature will return back to its original position, then it will slightly move to this direction again. Then what will happen, this it will help to rotate this ratchet wheel one direction clockwise. That means this wiper will come to position 1. For the next pulse, again we have make phrase, then again same thing will happen. This pulse again will catch on lower teeth. So ultimately this wiper will move to this position 2. Now this detent will help to retain its position. So what will happen? So after this dialing, let's consider we have dialed 6. So we have 1, 2, 3, 4, 5, 6 number of pulses. So again what will happen? This wiper for the next phase, after dialing this 2, this wiper will go to its original position, that means this initial home position. Now again this what will happen if we dial 6 again, so this will rotate 6 position and this wiper will come to 1, 2, 3, 4, 5, 6 in this position. Now it will correspondingly, it will know that first digit 2 is being dialed, secondly 6 is being dialed, likewise. Fine. So this is some unidirectional movement is happening over here. That means this ratchet wheel is moving the clockwise direction only. So this is basically called a unidirectional selector or uniselector. So we have a two motion selector as well. This is nothing but the same thing, slightly complicated. In case of uniselector, we have single series of contacts. In this case, we have numbers of contacts connected vertically, and this having very similar thing like wiper in previous cases. Now this basically this wiper is being connected with some kind of gear drive which is having some vertical as well as lateral movement. Fine. So for the first digit it will have some vertical movement. For the immediate second digit it will have lateral movement. That's how it will going to connect several numbers of subscriber. So this is basically the very same thing as like the previous cases, but having two directional movement. First, and for the first digit being dialed, it is having some vertical movement, secondly having some lateral movement. Okay. So problem with Strowger switch is basically this type of switch is basically open to nature. Fine. That means uncoated. This type of switch is basically uncoated. So some natural phenomena like weather, weather having some moistures, so it will have corrosions and oxidation as well. Some kind of mechanical wear and tear process is simultaneously continuously going on. So because of this wear and tear process, a lifetime of this kind of switch is very low again. So performance by the time of this kind of switch get deteriorates. And in case of telecommunication switching, we need a very accurate kind of switch. So certainly this type of switch will not fulfill the purpose accurately. So technology moved on. Crossbar switch. Switch is basically having some input and some output and some controlled connectors in between this. So what was the problem of Strowger switch is basically it was open to nature. So this problem is being solved. In case of Crossbar switch, we have some something like this, some connectors here, we have something like this here again, this is to point, some connection is coming to this direction, going back. Fine. So to connect this to point, and this has to come here, that means this has to come here, this has to come here, and that has to come here, like this, to connect this thing like this. And this entire thing is being encapsulated inside some bulb. This entire thing is encapsulated inside some bulb. This is called glass encapsulation. And some inert gas inside, just like some electric bulbs. Fine. So to have this kind of operation, basically we have we do require some electromagnet here. First of all, we have this type of thing. Let me draw that diagram again. We have now we have some magnetic portion here, we have some other magnetic portions here, we have some electromagnet over here, this is some electromagnet, we have another electromagnet over here. So thing is, this electromagnet will attract this magnetic portion, so that this will move here, and this electromagnet will attract this thing, and this will move here, and we have some encapsulation as earlier cases. This is basically a cross point. This is basically configuration of a cross point. So we have we have 4 number of subscriber over here. This is subscriber number 1, this is subscriber number 2, this is subscriber number 3, this is subscriber number 4, and we have cross points. This is say 1 dashed, this is 2 dashed, this is 3 dashed, and this is 4 dashed. So number of cross point here basically 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So we have 4 number of subscriber here, we have 4 cross 4, that means total 16 numbers of cross points, and each and every cross point will look like this. Fine. So if we have n number of subscriber here, there will be n cross n number of cross points. So complexity is basically O(n) square is the designing complexity. Fine. This is a crossbar switch having 4 number of subscriber. This is 1 2 3 and 4. These ones are these points, these are cross points, these are cross points. So we have some kind of control lines here, that means all the electromagnets with this vertical line have called column control. This is also column control, C1, C2, C3 and C4. This is called row control, R1, R2, R3 and R4. So whenever on of this C1, whenever this C1 is energized, then all these electromagnets connected with this C1 will get energized. Whenever R1 get energized, all the electromagnets corresponding to this R1 will get energized. Okay, so whenever this line C1 and this R on get energized, then what will happen? This C1 is activated, then on is activated. That means this two electromagnet is activated. So this point is in operation now. So this point is energized. So on will get connected to on dash. Likewise, fine. So these are the column control line, and these are row control line. So each and every cross point look like this. Each and every cross point will look like this. Okay. This is basically called crossbar switch. Now let's consider some issues. So we have a number of cross point, we have number of subscriber 4 here. These are the lines. Now if we want to connect this on, let's consider some example here. Say subscriber 2 wants to connect subscriber 4. Okay. So first ever thing is subscriber 2 is connected with this R2 row control. So first we have to energize this R2 line. Then all this electromagnet will get activated. Then now what about this column control? We have to connect this C4 column control. So first ever sequence is R2. Then we have to energize C4. Now this point is get activated, R2 and C4. So this point is get activated. Now if we activate this line again, so again R4 again, so what will happen? Some connection will get established from this point. So this is the cross point, this cross point. So these two cross point will get activated, so that this subscriber 2 can get access to subscriber 4. In this case, subscriber 2 is the calling subscriber and subscriber 4 is the called subscriber. Now the question is it mandatory to connect all the cross points or to use all the cross points? Let's have some particular scenario here. Basically this 1 dash, 2 dash, 3 dash, 4 dash can be called as output line, but not the subscriber. Subscriber is 4 here, 1, 2, 3 and 4. So we have 4 number of subscriber here. These are the 4 number of input lines from the subscriber. These are the output lines. So this 1 dash, 1 prime, 2 prime, 3 prime or 4 prime, these are not the subscriber. Fine. So let's consider the scenario here. Subscriber on, that means this 1 is connected to 1 prime, 2 is connected to 2 prime, 3 is, that means 3 prime is connected to 3, 4 prime is connected to 4. Fine. In this scenario, let's consider the cases here. All the subscriber, that means this exchange, particularly if you consider this as exchange, we have a 4 number of subscriber here, and this 4 subscriber should connect. Okay, that means should be connected, should be fully connected. That means we are considering the scenario that we have 4 number of subscriber, and each and every subscriber having liberty to call any of the rest subscriber without harming the already established call. That means what happens whenever let's consider some issues. Subscriber number 1 is connected to subscriber number 3. That means this communication is already happening. Now subscriber 2 wants to initiate some call. So for subscriber 2, subscriber on is busy, subscriber 3 is also not available. So subscriber 4 is available. So let's consider subscriber 2 wants to call subscriber 4 here. So it will not harm this path again. It will not harm this path. So subscriber 2 have to connect subscriber 4 by some other means. So likewise, any subscriber should not harm, that means any calling path should not harm the already established path. So if you consider the scenario here, so let complete all the connections, all the available connections, as the number of subscribers is very small. So let consider subscriber 1. The issue of subscriber on. So subscriber on can call subscriber 2, 3 or 4. So let consider this on prime line is basically dedicated to subscriber on. That means if subscriber on wants to call subscriber 2, then communication will go to in that way. That means this point is energized, this point is energized. So the on can call subscriber 2 in this way. Fine. If it is subscriber 3, that means subscriber on to subscriber 3, then this cross point, that cross point, not necessarily that cross point, this cross point and that cross point will get energized. So there will be some path between on and 3. If it is 1 and 4, then there will be this path. That means this point is energized now, not necessarily this point and that point, and this point is now energized. So there will be some path between 1 to this cross point to that cross point to 4. So reverse communication is also possible. But what will be the case if subscriber number 2 wants to communicate? So if subscriber number 2 wants to communicate, we will use this 2 dashed path. That means so from 2 to 1, from on to 2 in this way, 2 to 1 is also in this way, but if it is 2 to 3, then first ever thing will happen, this point will get energized. Okay, is it this point? Not necessarily this point. So connection from this point to that point, so that point will get energized, and again this point will get energized, so that will establish some path between 2 to 3. Okay, from 2 to 4 in that way. So this point will get energized, from here to this point will get energized, and from there to this point 4. Okay, no issues. Now if subscriber 3 wants to communicate with subscriber 1, so it will go in that way. If subscriber 3 wants to connect subscriber 2, so it will go to this way. That means this point will get energized, then this point will get energized, and from here to 2. Now if subscriber 3, then this 3 dashed, that means directly from here to here, so this point will get energized, this point to that point, and to subscriber 4. Now what will be the cases of 4, subscriber 4? So it is if it is 4 to 1, that means 4 is calling subscriber, 1 is the called subscriber, then communication will go to in that way. If it is 4 to 2 in this way, 4 to 3 in this way. So basically if we connect, and that means whatever assumption we have used earlier, that means if we connect this point on prime to 1, 2 prime to 2, 3 prime to 3, 4 prime to 4, in this case we just require this lower diagonal or even upper diagonal of cross points. Not necessary all the 16 cross point is in use. So basically we require, if we use these lower cross points, we need n into n minus 1 upon 2 number of cross points. If we use upper cross points, it will be n into n plus 1 upon 2. So both of the cases complexity is O(n) square again. And if we look on thing, this cross point we are not using actually, but we just considering this thing to simplify these issues or to include all the diagonals elements. Okay. So these are the crossbar switching. So problem with this crossbar switching is basically, again, if you implement this thing for a large network, that means any exchange having numbers of a huge number of subscriber, to implement this type of switching system is very difficult, and to maintain all the connections, it is very difficult again. Fine. Again, this kind of switching is not efficient on again. So better we should go for some kind of stored program concept, that means digital kind of switching. And in the advent of computers and microprocessors, this will become very easy concepts. So I think we should stop today here. We'll discuss electronic switching from next class onward. Thank you.